morning, all of you. Myself, Sankeerth. I'm currently studying in third year of BE, pursuing AIDS, Artificial Intelligence and Data Science course in NIT Meenakshi Institute of Technology. So, in the Samsung Innovation Campus of Capstone project, I have selected eye disease detection and classification project using deep learning and neural networks. So, one quote I have to say: detection or early diagnosis is better than late realization. So like many eye retinal damage causes vision loss. It may cause a major life threat. Due to vision loss, no world is being seen. So to detect the disease, early diagnosis by my project is very helpful for people, and it reduces major screening population time. Like when you go to the hospital to eye checkup, if there are thousands of people, then much more time it takes for a specialist, and there should be also equipments. So and most of the time it takes, and then specialists are required. So due to overcome all this, so my model predicts which disease retinal fundus image contains. So my dataset consists of 10,307 images of various disease, and my dataset is classified into 5 classes. That is, one is myopia, macular scare, and diabetic retinopathy, and one is normal, and one is now moving on to the code. So I have imported all the libraries. Operating system is used for extracting files and major like files and folders to extract all this, and then NumPy for mathematical calculation of weights, and pandas for a data frame, and TensorFlow used for deep learning architecture building models. And also I have used model EfficientNet. Why I have used EfficientNet is like to I am having a mid-range of data set, that is 10,000 images, and EfficientNet consists of 5 million parameters of weights, and it is useful for fast training also. So this is why I have used, and also I have used callbacks like early stopping, reduce LR, and the model checkpoint. Train test script, classification report. These are the metrics for predicting. This is a dataset path. I have used inbuilt dataset, and image paths and labels. This is an image path, and this is the label. Each image path is converted into the label of 0, 1, 2, 3, 4 for numerical. The TensorFlow accepts only numerical. It doesn't accept any categorical values. Numerical values it has. And then stratified train validation and test split I have used. The training is split into 70%, and the testing and validation is split into 15-15, which is 30%. So you can see the labels 0, 1, 2, 3, 4 are split approximately equal, like 1400, 1300, 1400. And I have uploaded a load image function, which reads the every image and then decode image to JPG. If any files contain like only path code, it converts into JPG or PNG by specifying it. And then image resize. The efficient model only accepts 224 by 224 input size. So I have rescaled it, resized it. And then I have used class weight adjustment. So why I have used class weight adjustment? If my model, if the dataset contains of any minority class, if it ignores the minority class, then the model will be biased. So to overcome this, I have used class weight adjusting. The model when the model punishment when the model ignores the minority class, the model get punished. And say you should not ignore the minority class, and you should keep the equal weightage of the majority and the minority. This does by class weight adjustment. You can see zeroth class is 98, and one class is 98. Like that, it is distributed equal each class. And the model. So base model. So I have divided the model into two phases, like by like fine tuning. First layer. So first of all, I have put include top is equals to false, which freezes the all layer trainable layers. Why? Because I have to train my own classifier dataset, so that I freeze my model ImageNet weights model, and then I've used global average pooling, batch normalization, and dense. So global average pooling is used to convert the feature map output into a specified vector in feature vector, and the feature maps average should be taken as feature vector, and the batch normalization is used to normalize each layer's output and before going to the next layer. So optimizers is used, Adam is used, and space categorical cross entropy is used for loss, and matrix accuracy. And the callbacks, the early stopping callback is used for when model hits the patient's 5. After 5 attempts also, the model did not improve its accuracy or validation accuracy, the model automatically stops. This is early stopping callback. And reduce LR, like if the model accuracy didn't increase after patients of 2, then the factor of 0.3 is reduced for the learning rate. And the model checkpoint, if the model hits a best accuracy, then the model will save. Here checkpoint is used for the best model. And firstly, initial approach I have taken 15, and then by unfreezing all the trainable layers, not all, only top 50 layers. I have trained only top 50 layers by unfreezing it, and I have got a training accuracy of 83%, and validation rate as 77%, and testing accuracy 70%. And these are the images of diabetic retinopathy, macular scar, myopia. So these are the 9 images. So this is the training and validation accuracy, and training and validation loss. This is the classification report. So here confusion matrix there are around 320 320 images. In that, 300 is correctly identified as diabetic retinopathy. Here we are having 300 in which a 185 as correctly identified as glaucoma, in which 258 as correctly identified as healthy, and 245 correctly identified as macular scar, and 234 as correctly classified as myopia. This is the confusion matrix. So I have used a image path of diabetic retinopathy image, and it has predicted with a confidence score of 99.97 diabetic retinopathy. So I am now going to show the web application of this. So before going into the web application, I need to clarify one thing. Instead of using manual screening techniques, and it requires also maximum specialist doctors and equipments, my model predicts which disease a person has by only uploading the retinal fundal image. So it has correctly predicted as myopia, 99% confidence score. And it also gives a description of the myopia and common symptoms like difficulty seeing distant object and eye strain, headache, squinting, and recommended precautions and suggested treatment it also gives. You can also upload different image. So it has correctly identified as diabetic retinopathy. The confidence. This is my model. Thank you.